live. This is Math 60, Intermediate Algebra, and we are in chapter 9, and we are just knee-deep in logarithms, and so I brought in our friend Godzilla to help with the logarithms, because I don't know, looking at Godzilla, I just feel, happy and ready to do some logarithms. So 9.6 is, taking the weird and making it weirder. We're going to go into some properties of logarithms. So first thing to say is there are a lot more in the book. You can totally geek out. Logarithms it's its own study. You could spend months studying logarithms, and we're not going to. We're just going to look at a few. And I'll remind you that bases should be greater than 0 and should not equal 1. So let's take a look at log base a of a to the x. So log base a of a to the x. Notice that I've got my logarithm. I've got my exponential. So here's the log. This is the log. And here's the exponential. And remember how square root and square undid each other? Log and exponential kind of cancel each other out. And so all you get is x. They literally cancel each other out. They're inverses. So the next few problems will be really easy. Let's start off with log base 3 of 3 to the 4th. Don't even think about it. Don't even consider what 3 to the 4th is. Don't even think of 81. Just go ahead and see that we've got log base 3 of 3 to the 4th. Log base 3 of 3 to the 4th. And all of this kind of cancels itself out, and all you get is the 4. Pretty cool, huh? Okay, now this one's not as easy. I've got log of 1,000. So what I've got to realize is this is log written without a base, which means it's log base 10. So can I put 1,000 into tens? 10 to what is 1,000? 10 to the 3rd. Log base 10 of 10 cubed is just the 3. Okay, same thing. I've got another common log. Should have equals. Log base 10 of 0.01. That's log base 10 of 1/100th, which is log base 10 of 1/10 squared, which is, I'm getting there, log base 10 of 10 to the negative 2. So that means the log base 10 of 10 cancels itself out, and we get negative 2. So we just get the power. Notice the pattern. We just get the 4, we just get the 3, we just get the negative 2. Woohoo! Okay, so that's the first one. Logarithm and exponentials cancel each other out. It turns out going the other way around also cancels itself out. So what is the other way around? Well, if we take a and raise it to the power of logarithm, the a raised to the power of logarithm also cancels itself out. See how this is an exponential and this is a logarithm? So we're smashing them together. When you smash them together, they are like matter and antimatter. I don't know which one's matter and which one's antimatter, but the two of them together, mutually assured destruction. That's why there's been a Cold War between the exponentials and the logarithms for decades. So together, so e to the natural log of 4. So in other words, e to the log base e of 4, pew pew, and we've got 4. Log raised, 10 raised to the log of 5. That's 10 raised to the log base 10 of 5. Pew pew, we get 5. So logarithm and exponentials undo each other. They can't cancel each other out. They are inverses. Okay, what's coming on this page? Another cool fact. These shouldn't be called properties. These should be like super cool facts. This is one of the weirder ones. log base a, so any logarithm, of an exponential. Now, this is kind of what we were doing over here, right? These, so it's kind of related to what we were doing before. But if the argument of logarithms, so the thing you're taking the log of, has an exponent, the exponent flies down in front. This is one of the coolest and most useful things you could ever do. So what does that look like? Well, here it would be log of 1,000 is 10 cubed. So this is log base 10 of 10 cubed. Now, I already told you that these cancel out and we get 3, but let's look at what it does. This 3 comes down in front, and we can write it as 3 log base 10 of 10. How many 10s go together to make 10? Oh, just one. Oh, okay. 3 times 1 is 3. Same thing here. Log base 2 of 8 is log base 2 of 2 cubed. The 3 can come down in front, so we can have 3 log base 2 of 2, which is, I'm running into the other one, 3 times 1. Apparently I was totally into 3s when I wrote this. So exponents can come floating down. We're going to play with that a little bit. 4. This is an interesting little property called change of base. So in change of base, and this is one of the weirder things, and this is really useful because if I say I have log base 3 of 7 and I say find it on your calculator, you'd be like, there is no log base 3 key unless you have a fancy calculator. And I'd say, don't worry about it. You can write it as log of 7. See how 7 is higher than 3? So either write it as log of 7 over log of 3, or write it as natural log of 7 over natural log of 3. Honest to goodness, the ratios stay the same. So if it's not too dark, it's a little bit dark. Move into the light, Carol Ann. Okay, so there we go. So if I do log of 7. Now, remember what I've said before. Be really careful about parentheses. If I don't notice that this is going to be a problem, I end up with a big problem. So log of 7, enter parentheses, divided by log of 3, close parentheses, equals. And then I get 1.77.1243749 da da da. Okay. Come into the light, Caroline. There's peace and serenity in the light. Okay, so that's poltergeist. The first one, the original one. Okay, so natural log of 7. What if we did natural log divided by natural log of 3? Exactly the same number. Magically delicious. So if you want to calculate a funny base, all you have to do is you can use natural log or log. Be consistent top to bottom. Use the same one. Don't try to mix them up. That won't work. And then whatever the base is goes on the bottom, and whatever this argument here is goes on top. That's it. So log base 3 of 7. So that says how many 3's multiplied together give me 7? And the answer is, well, almost 2, but not quite 2, because 3 squared is 9. So that's too big. So it's slightly less than 2 3's. Kind of, sort of. Woohoo. Okay. Let's simplify. Log base 3 of 3 to the x. The log base 3 of 3 cancels itself out, and we get x. Okay. What about 5 raised to the log base 5 of x? That's also equal to x. What about log base radical, log base 10, so common log of radical x. Well, let me remind you, this is log of x to the 1/2. So another way to write that, log of x over 2. Kind of woohoo. How did that happen? Well, the 1/2 comes down. So we get 1/2 log of x. So it looks like that. So what would that look like? Well, what if I did number 4? What is the log of the square root of 10? Well, that would be the log of 10 to the 1/2, which is equal to 1/2 the log of 10. Now, common log of 10 is 1, so that's 1/2 times 1, so that's just 1/2. Woohoo. So this is just kind of a taste, an amuse-bouche of logarithms to get you ready for all the super fun times you're going to have with logarithms in your next class. So hopefully this is a good introduction. Woohoo. And yay, math on. Have fun with logarithms.